Good morning, everyone. Today I'm dealing with the topic OpenGL 3D transformations. OpenGL 3D transformations, functions, okay? And the functions which is available in OpenGL, we are learning under these topics. Okay, the functions available under these three scenarios, we are actually dealing in the today's topic. OpenGL geometry transformation, matrix operations, matrix stacks. Okay, let us learn one by one. Before going to OpenGL geometry transformation, let us learn some of the basic concept that we are assumed or that is assumed in OpenGL package. Okay. In our core library of OpenGL, a separate function is available for each of the basic geometric transformations. Which are the geometric transformations we have? Translate, scaling, rotate. Shearing and reflection is usually, it's not a basic, it's an advanced. So basic, only three we are dealing here in our syllabus. So here, OpenGL is designed as a 3D graphics API where all transformations are specified in 3 dimensions. So 3D graphics APIs are designed in such a way that all the APIs are designed for 3D purpose, not for 2D purpose. Fine. So 3D is implemented on 3D APIs. We will apply a 2D scenarios. Okay, we will see how it is. So we don't have separate 2D functions and 3D function, especially for geometric transformation functions. Okay. Internally, all coordinate positions are represented as 4-element column vector. So that means our coordinate positions are X, Y, and Z. Fine. Which are the coordinate positions? A coordinate position for each and every point P is nothing but it is X, Y, and Z. Okay. We have 3 coordinate positions, but this coordinate position is actually 4-element column vector. It is a column vector. We have one more addition to this, which is nothing but a homogeneous coordinate system. That is what they're trying to tell. All transformations are represented using 4x4 matrices. Our matrix, we have 4x4. 3x3 is our 2D. As we are not implementing a 2D concepts with respect to the transformations, there is only one matrix, which is that 4x4. We don't have 3x3. It's only theoretical we will learn, but the implementation way in OpenGL package, we have 4x4 matrices. Performing 2D transformation within OpenGL is generally just a matter of using a value for the transformations in the third, that is nothing but in the Z dimension that cause no change in that dimension. So if you want to perform 2D, because we are learning that OpenGL has all 3D functions. So if we want to perform 2D transformations, then we need to operate on Z. We need to operate on Z. So it's quite easy, it's not difficult here, which cause no change in any of the dimensions or in any of the values. Let's start seeing one by one about the functions. So what is the first function we are learning here? The first function we are learning is glTranslate function. And then we will learn glRotate and glScale. All these three functions has star. Star indicates F or D. Star indicates F or D. Star indicates float or double. That we will find in all the three transformation functions. Fine. So now we will see a translate. So translate, we have a 3 translate parameters, that is tx, ty, and tz. So how do we use it? So our function GLTranslate, every function, as you know that the first two letters GL, GLU or GLUT will be in a small case, and the next word, every word starting letter will be capital. So star, either you replace by F or D. What is Tx, Ty and Tz? Can be assigned with any real number values. Fine, any values. For two-dimensional applications, we will put Z is equal to 0.0. In the Z place, we place what? 0.0. Otherwise, other than 0 if you place, then it applies a 3D transformations or 3D translate functions. Two-dimensional position is represented as 4-element. Even two-dimensional represents as a 4-element column matrix with the Z component equal to 0.0. So what they're trying to tell here is I have 4 cross 4 matrix. Tx, Ty, Tz is in the 4th column. 0, 0, 0, Tx. If I have a Tx, then it is 2. Okay. Well, let us see here what I have. 25. So Tx is I have, it is 25. In the same way, in the Y, 0, 0, and then 0, it is minus 10. Fine. Like that. The third one will be 0, 0, 0, and Z. As if I want a 2D, then keep your Z as 0. So this is 0. The fourth one, 0, 0. This is a homogeneous, usually a 4th row. It will be 1. So this will be our matrix. So this is a 4 cross 4 matrix. It is not, even though it is a 2D, it is not 3 cross 3 matrix. It is 4 cross 4 matrix. Our Z value will become 0. So we should not worry about the Z value to use. Now next we will go for a rotate function. Rotate over theta degree around axis X, Y and Z. GLRotate theta, Vx, Vy, Vz. Theta is my first parameter. X, Y, Z is nothing but a coordinates. So vector V, all these 3 coordinates is a vector itself. Defines the orientation for a rotation axis. In which axis they have to rotate, so that they have to use that respective matrix. Because we have in the 3 dimensions, we have 3 matrix for the rotation. Rotation with respect to X, rotation with respect to Y, rotation with respect to Z. So to know all these 3 dimension matrix, in which direction we have to rotate, so we have to keep this either one, okay? So next theta. Theta is nothing but an angle, how much we need to rotate. So it is a degree, it will be in the form of a degree, but automatically we have a routine or a function inbuilt which converts the degree to radian for any kind of a trigonometric calculations. Vector V, I call it as a unit vector. We assume it as a unit vector. So rotation in 2D system is rotation about the Z-axis. Now here we are trying to implement rotation in a 2 dimension, where I will see Z-axis will be should be equal to 1. So any axis if you want to use, you should only use 1.0 because we have already told it is a unit vector. Either 0 if it is not rotating with respect to those axes, or 1 if it is rotating with respect to any of the axes. So in 2D, what I will do? I will use 1 for the Z-axis, because the 2D rotation, have you have already seen the matrix, 2D matrix is equal to Z-axis rotation in the 3D. That's why whenever we are using 2D, we will See to that it is rotating with respect to z-axis. So let's see the example here. You're rotating F. F is my star, replaced star. F is a floating value, so I'm using a floating value here. 90 degrees is my theta. 0, 0, because I want to use with respect to z-axis. So z-axis will be 1.0. If you want to use with respect to x-axis, then keep x-axis as 1.0 and y-axis as 0.0 and z-axis as 0.0. Okay, 0.0. Fine. OpenGL 3D transformations with respect to GLScale. GLScaling has a factors Sx, Xy and Sz. Again, star stands for F float or double. Sx, Sy, Sz is can assign any kind of a real number values. As usual, scaling in 2D systems involves changes in the x and y dimensions and a z scaling factor of 1.0. If you want a 2D scaling with respect to 2D, then see to that the 2D will have z-axis will have 1.0, which cause no change in the z coordinate positions, because in scaling the value, the formula that we use is x into sx, s into sx. Fine. So when you have an into here, if you multiply with 0, everything will become a 0 here. So if it is a z coordinate here, then multiply. So this is not possible. So multiply this by 1, then it retains the same value. If I multiply, I get the same value of x. If z is 0, multiply z with 1. Fine. And there is one more point that you need to know here is, so whichever the axis, especially in 2D, z-axis will be 1. So here, this is my example for 2D with respect to 2D scaling. So I am using scaling with respect to x-axis 2 units, scaling with respect to y-axis 3 units. You can use minus also here. And z will be 1. Why have we used 0 in the z value, 0 in translate function, but in scaling we are using 1? Why is that so? Because 0 has x plus tx formula. You have an addition. So for any kind of a value, coordinate axis value, if you add 0, I will get the previous the same one, existing one. But in the same way, this is x into, so when I multiply, if I multiply by 0, everything will become 0. So I have to make it as a 1 here. One more important note we should see here, that is, we should see to that either in Sx, Sy or Sz, we should not use 0 any times. It will become a processing error. Why it will become a processing error? Because the composite transformation what we have, most of the cases, the objects, the complex objects we will be drawing in the OpenGL. Drawing in OpenGL, complex objects will be drawing in OpenGL. So most of the time when we have a complex object is drawing, composite transformations will be applied. So when we are using a complex or composite transformations, in composite transformation we will have inverse also. What is a scale inverse? The inverse of scale, as you already know, it is 1 by Sx, 1 by Sy and 1 by Sz. So when the denominator is 0, then we'll buy a divide by 0. We will encounter a divide by 0, system error. So in order to avoid that, So we don't use zeros. So next we will see some of the matrix, OpenGL matrix operations. In OpenGL matrix operations, we have GL matrix mode. GL matrix mode, let's see what is GL matrix mode. GL matrix mode has a parameter, two parameters in our syllabus, GL projection and GL model view. Apart from this, we have two more, that is a texture and color. As we don't use those two parameters in our VTU syllabus or in our prescribed syllabus, we don't deal with that. We deal only with the projection and model view. So what is a projection and model view says? GL projection says that the matrix that is to be used for the projection transformation, this transformation determines how a scene is to be projected onto the screen. Here we have how the scene is projected onto the screen. How a scene is projected onto the screen is told in the two kinds of functions, whether it is an orthogonal function or it is a perspective function. We will learn in the fourth module. Orthogonal, currently till now we are using only orthogonal projections. And in perspective projection, we have a concept of zoom in and zoom out. And both in orthogonal and perspective projections, we have a reshape function which will be dealing with an aspect ratio. So this zoom in, zoom out, aspect ratio, perspective projection, orthogonal projection, everything is a parameters or factors that is applied on the camera. So to store the matrix which is relevant, so all the camera related informations or the matrix, camera related information is stored in the separate matrix, which is GL projection matrix. So before we call any of these viewing functions, that is ortho, we should say that I am keeping ready for you a projection matrix. Now you can store all your viewing functions in the projection matrix. So GL model view used to store and combine the geometric transformations. That is, now I have a separate matrix stack which is used to store the geometric transformations. So what is geometric transformation? You translate, rotate and scaling, etc. Because even that has to be applied through the matrix. So again, matrix, we need a stack. So that separate stack is nothing but a model view. Any kind of these, if you're applying, then you have to apply in this model view matrix. So before you use these geometry transformation, you need to call model view. Let's see with examples, all those. By default, the GL matrix mode function will have GL model view. It's not GL projection, it will have GL model view. Please remember that. Once we are in the model view mode, a call to the transformation routine generates a matrix that is multiplied by the current matrix for that mode. So any in the matrix or a stack, any kind of a matrix is stored inside the stack. Then if a next matrix, if you're storing, that will be multiplied with the current matrix. We will see that how it is. Before we see an example of how it multiplies, we will see what is GLoadIdentity and GLoad matrix. We can assign the values of the elements of the current matrix, and there are two functions in the OpenGL. So that means current matrix we can store, we by default we can force to store some of the values in the form of a matrix in a two ways, two functions. One is with the GLoadIdentity and one is with respect to the GLoad matrix. GLoadIdentity initializing the matrix to identity matrix. That is by calling the function GLoadIdentity. Alternatively, we can assign other values also. This is just assigning the identity matrix. If you want to assign a separate matrix to the current matrix, then I will use the function GLoad matrix. GLoad matrix, any kind of a matrix will have this scenario, that is nothing but we call it as a column major order. What is column major order is exactly opposite to the maths concept. Usually in the maths concept, the concept is it will be in a row major order, any matrix. But here we have a column major order. Column major order is 0, 1, 2. It depends upon the implementation or of the software or a package. There are many other packages uses the row major order. So any element stores first column wise. One first element, second element, third element, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12. So element stores in the form of a column. The first column will be filled, followed by second column, followed by third column, and then followed by fourth column. So now, if I want to store this matrix to the current matrix, onto the current matrix, which is there in the model view matrix mode, then we can pass this. If I assume element 16, it's some array which has 16 element array of floating point, because assuming we have given a float f here with a parameter element 16 and a suffix code either f or d, which used to designate the data type. Let us see how does it work. To illustrate the ordering of matrix, we initialize the model view matrix with the following code. Example, I'm calling a model view matrix currently, GL float. Assuming a model view will have a load identity initially, GL float, 16 array position we have taken. K is for the for loop. I've used a for loop just to fill the array position. Elements of 0 will have float K. It's nothing but 0.0. Okay. And what is the content of elements now? The contents of elements will be the first element is nothing but element of 0, which I call it as a 0.0 because I'm talking it as float of k. What is k? K is actually 0. Increment, go back, elements of 1 will have the value 1.0. Fine. Element of 2 will have 2.0. So like this is the value. It's a simple way that I'm storing the 16 array position in the 4x4 matrix. Then what I'm doing now, I got this is my elements, ELEMS array name that I'm storing. I'm telling load matrix F now. This complete array will go and store in the model view matrix. These complete elements, that is nothing but this is my array values which stores in the model view. So like that, you have so many options to store the array. We can also concatenate a specific matrix with the current matrix. So if you want to concatenate, means apart from your transformation functions automatically gets concatenated. Apart from that, if you want any other function to concatenate with the current matrix, then you have GL matrix. Okay. So that is nothing but multiply the matrix. That is nothing but other elements. By default, your translate, rotate, and scaling will be stored. You would have given a parameters, but automatically that stores in a matrix form. So matrix form obviously gets converted. Apart from those three, if you want to pass any kind of a matrix, then you have a load matrix one option and multiply. This is to multiply. Again, the suffix code is either F or D. The current matrix is post multiplied by the matrix specified in the mult matrix, and this product replaces the current matrix. Say that the current matrix, whatever is there, gets post multiplied by a matrix specified in the what is post multiplied. Let us see an example for this statement. I have a matrix mode. I am calling it as a load identity, sets the matrix to the load identity. Actually, this scenario currently in the new version is not required. Automatically, model view matrix stack will have a load identity itself. So, but let us deal according to the textbook, that is Hernand Baker. Let me assume this is my model view stack, matrix stack. What I have load identity. When I have load identity down, what can be the next one? Mult matrix is nothing but M2. So M2 will come and sit here. That means I am telling that please multiply this with my current matrix. What was the current matrix? The current matrix was load identity. So now load identity and M2 gets multiplied. Okay. So these two gets multiplied now. These two gets multiplied and the result stores on the current matrix. So assume, let me cancel this. It's gone. Now my current matrix is here, which is M2. Okay. My current matrix is M2. So now again, next again I'm telling please this matrix please get multiplied with the current matrix. Whenever you say GL mult matrix, it gets multiplied. So then the current matrix is post multiplied. What is the current matrix? M2 is post multiplied. What do you mean by post multiplied? That is nothing but M2 gets post multiplied. Yes, M2 gets post multiplied. M2 is in the current matrix with the GL mult matrix, whatever I'm calling now. The same thing happened in the first scenarios. It's nothing but M1. Okay, this produces what? Model view matrix M is equal to M2 into M1. Because we already know load identity is nothing but I get M2 only. So I don't have to explicitly show load identity into MT into M1. So hope you have understood this. The first transformations to be applied. So let me clear this. There is calling. The first which you have to note, this point please see to that you note it. The first transformations to be applied in the sequence is the last one specified in the code. So whichever the first matrix you want to apply, that will be the last to specify in the code that you need to remember, because we also know how is our composite matrix also works, right? So according to that you have to work. My composite matrix works like this. The first one I have to put it here. Then any kind of a rotation, and I can say it is a next again I can call it as a translate inverse. So if you want this to be multiplied, so that is nothing but I will say T inverse is post multiplied with R and the result of that is post multiplied with T. So if you want to get in such a way, in this way, then you see to that your code should be like this. Your code should be